Hello students, we are going to start chapter 15, light. In this chapter we are going to learn the rectilinear propagation of light, reflection of light, images, spherical images, lenses and dispersion of light. These are the topics which we are going to do. So first we are going to see what is rectilinear propagation of light and reflection of light. Rectilinear propagation of light. The property of the light that it always travels in a straight line is called as rectilinear propagation of light. Now, the light travels in a straight line. So, this is called as the rectilinear propagation of a light. Suppose if we take we can do one activity like to show light always travels in a straight line. So take one candle, a straw and a candle stand. Light the candle and fix it on a candle stand. Now keep the straw straight and observe the flame. Can you observe the flame? Yes, we can observe the flame. Now bend that straw. Now try to see the flame. Can you see the flame? No. So candle flame is visible when the straw is straight and it is not visible when the straw is bent. This proves that the light always travels in a straight line. So this is rectilinear propagation of light, that the property of the light that it always travels in a straight line. Then reflection of light. The phenomena in which the light falling on the surface of the object is sent back by the surface of the object is called reflection of light. Once again, I am repeating, the phenomena in which the light falling on the surface of the object. Suppose if we take a mirror, the light falls on the mirror and it is sent back. When it strikes that mirror again, it is sent back by the surface of the object. So this is called as reflection of light. Polished surfaces reflects the more light as compared to the rough surfaces. Next, real images, the image that can be formed on the screen. So what are real images? The images which can be formed on the screen are called as real image, and the images which cannot be formed on the screen are called as virtual images. Lateral vision, the property of reversal of the side of an image formed by a plane mirror. The property of the reversal of the sides of an image formed by the plane mirror is called as lateral inversion. Suppose you might have observed that the word ambulance on the ambulance vehicle is written in the reverse. Why this is written in reverse? This is because when the reverse word ambulance get reflected in the rear view image mirror of the vehicle moving ahead of the ambulance, the driver can read that word correctly as ambulance and give the way to it. So that is lateral inversion, the reversal of the side of an image formed by the plane mirror. So whenever you see ambulance, you will see the word ambulance written in the reverse, so that the people who are driving, they can see the ambulance. If the ambulance is coming, they can read the word ambulance correctly and they can give the way to it. So what are the characteristics formed by the plane mirror? The image formed by the plane mirror is always virtual and erect. So the image which is formed by the plane mirror is always virtual. Means what are virtual images? Images that cannot be formed on the screen are called as virtual image. So plane mirror always forms a virtual image and erect image. The image undergoes lateral inversion. Means your right in the mirror, it is appeared as left and your left is appeared as right. The size of the image formed by the plane mirror is same as that of an object. Whatever the object size is there, the image size will be also same. And the last one, the distance of the object from the mirror is equal to the distance of the image from the mirror. So if you are standing 1 meter, if you are standing half meter from the mirror, then your image is also half meter away from the mirror. So the distance of the object of the mirror is equal to the distance of the image of the mirror. These are the characteristics of the image formed by the plane mirror. Next, spherical mirror. What are spherical mirrors? The curved reflecting surface formed the spherical mirror. You can if you have seen the spherical mirror, you can see that the curved reflecting surfaces form the spherical mirror. The spherical mirror are of two types: concave mirrors and convex mirror. Now, what are concave mirror? Concave mirror is a spherical mirror whose reflecting surface is on the inner side, and it is also known as converging mirror, whose reflecting surfaces are in the inside is called as, on the inner side is called as concave mirror. Concave mirror can also be called as converging mirror. Why it is called as converging mirror? Because as the parallel beam of light after reflection from the concave mirror converges at a single point. So as the parallel beam of light falls on the concave mirror, after reflection they meet at one point. Converges means meet at point, so it is called as converging mirror. Similarly, convex mirror. Convex mirror is a spherical mirror whose reflecting surface is in the outer side. See, the reflecting surface, if it is an inner side, is concave mirror. If the reflecting surface is on the outer side, it is called as diverging mirror. And diverging or convex mirror. So other name of the convex mirror is diverging mirror. Why it is called as diverging mirror? Because as the parallel beam of light after reflection from the convex mirror, they diverge. If they meet at a point, they are called as converging mirror, but if they move away from the point, they are called as diverging mirror. Okay, so after reflection from the convex mirror, they diverge, they move away, they don't get meet, so they are called as diverging mirror. Now, uses of spherical mirror. Where the spherical mirrors are used? Okay, spherical mirrors. So spherical mirrors are of two types: concave and convex mirrors. So we are going to learn about concave and convex mirrors uses. So concave mirror is used of a large focal length are used as the shaving mirror. So concave mirrors can be used as the shaving mirror. Why? Because you can see the small hairs which are present on the face as the big one. Concave mirror are used as reflectors in the headlights of vehicle and searching light. So they are used as the reflectors in the headlights of the vehicle and the searchlights. Also we have concave mirror. Concave and convex mirror are used as the used in the reflection telescope. They can be used in the reflection telescope. Concave mirror are used in the devices of solar cookers. They are used in solar cookers. Convex mirror are used in the buses, that helps the driver to see the whole bus. So they are used in the buses also, as they can help to see the whole bus. So convex mirror are used as rear view mirror of vehicles. So in the vehicles we have a mirror, they are convex mirrors. Next, moving on to the lenses. Lenses. A lens is a transparent material with two surfaces, out of which at least one is a spherical surface. So lenses is nothing but it is a transparent material with two surfaces, out of which at least one is a spherical. One is a spherical surface. One, it is having a spherical surface. Next, there are two types of convex lens. There are two types of lenses. As we are having two types of mirror, we are having two types of lenses: convex lens and concave lens. Now, what is convex lens? Convex lens is also called as converging lens. So other name of convex lens is converging lens. Since they converge a given parallel beam of light passing through them, they meet at one point. After reflection, all the parallel beam of light meets at one point, so they are called as converging lens. They are thicker at the middle and thinner at the edges. They are thick in the middle and thinner at the on the edges. So similarly, concave lenses are also called as diverging lens, as they diverge the parallel beam of light passing through them, and they are thinner at the middle and thicker at the edges. Next, what is principal axis? A straight line passing through the center of curvature of the lens. If a straight line is passing through the center of curvature from the center point of the lens is called as principal axis of the lens. Optical center. The point of the center of the lens that a light ray passing through it emerges from the lens undeviated from its direction. So it is called as optical center. Once again, I am repeating, what is optical center? Optical center is nothing but the point of the center of the lens. The point at the center of the lens such that the light ray passing through it emerges from the lens undeviated. Means without moving in any direction, it comes undeviated from its direction, is called as optical center. Next, focal length. The distance between the principal focus and optical center. The distance between the principal focus and optical center is called as focal length. Next, image formed by the convex lenses. So these are the 6 images that have been formed by the convex lens. See, if the object is between f1 and 2f1, so image will be formed beyond after 2f2. Similarly, if the object is present at f1, then the image will form at infinity. When the object is between f1 and optical center, then the image is formed at the back of the in between 2f1 and f1. Similarly, if the object is at 2f1, the image will form at 2f2. If the object is beyond at the back of 2f1, then the image will form between f2 and 2f2. If the object is at infinity, then the image will form at f2. So these are the images formed by the convex lens, 6 images. Similarly, image formed by the concave lens. If the object is at infinity, the image will form at f1. If the object is between if the object is between 2f1 and f1, the image is formed between optical center and f1. So in this way, the image is formed by the concave lens. Uses of convex and concave lens. Convex lens are used as an magnifying glasses. Magnifying glasses, you know what is magnifying glasses. So convex lenses are used, that is convex lens. Convex and concave lenses are used in correcting the defect of eye. Suppose if a child is suffering with the eyesight problem, so we can use concave and convex lens for correcting its defect. Next, concave and convex lens are used in the cameras and for the projectors. So they can be used for the cameras and projectors. Similarly, concave and convex lens are used in the telescopes and microscopes. These are the uses of convex and concave lenses. Next, dispersion of light. Dispersion of light. The splitting of light into 7 components colors. The sunlight is made up of 7 colors. When this light splits into 7 colors is called as dispersion. You might have seen the rainbow. It is made up of 7 colors. So that is dispersion of light. Spectrum. The sequence of the colors obtained when the light undergoes dispersion. The sequence. The sequence of the colors like violet, indigo, blue, green, yellow, orange, red. So when these sequence of colors are obtained when the light undergoes dispersion, that is called as spectrum. We see in the rainbow the 7 colors. So that is spectrum of light. Different colors of the rainbow is formed due to the dispersion of light of sunlight passing through the small water droplets in the air after the rain. So after the rain shower, you know that after the rain shower you see the rainbow. So how the rainbow is formed? See, when the sunlight passes through the water droplets which is present in the air. So after the rain shower, the atmosphere, they contain the water droplets. When in these water droplets, the sunlight passes through it. The different colors that are formed is appeared in the form of large curve in the sky which is called as rainbow. When the sunlight passes through the water droplet, it undergoes dispersion. When it comes out in the form of 7 colors. Okay, that is, the water droplets acts as a prism. It splits the white light into 7 colors. So which appears in the form of a large curve in the sky which is called as rainbow. So in this way the rainbow is formed. So till here your chapter has been completed. Thank you.